Hi guys, in this video we are going to see about what is Kubernetes and why it is so popular. Before understanding what is Kubernetes, we should have knowledge on what are virtual machines and why they are used, which has something relatable to Kubernetes. So let's see what is a virtual machine. Normally, our laptops and computers have the hardware and physical tangible components that are used to store files and perform operations. If these hardwares such as CPU, memory and disks are virtually available as a code, then it is said to be a virtual machine. So, these virtual machines are generally considered as virtual environment that has its own operating system and it needs a real computer to execute, which are equipped with hypervisors such as kernel based virtual machines, shortly known as KVM. These hypervisors are responsible for sharing the resources from the local machine to the host operating system of the virtual machine. So, simply using a virtual machines in a computer are likely said to be using a computer inside a computer. Okay, why these virtual machines are created? Certain applications run based on the specific OS capabilities. They require deploying much different hardwares and dependencies and many installations to manage the working of that application. So, to deploy different applications with different OS capabilities and requirements, virtual machines are created. Hence, with the use of virtual machines, we can run multiple applications with multiple operating systems. But there are some consequences. Consider there are 5 virtual machines are created and sharing the original operating system. If currently one application is running inside a virtual machine, then the other virtual machines should be idle with the wastage of resources. And when many applications run in VM, it may result in overloading the original operating system as well as the virtual machine's operating system. So, to overcome this problem, Kubernetes concept is introduced. Now, let's see what is Kubernetes and how Kubernetes are handling the applications. So, what is Kubernetes? Kubernetes are container-based microservices which manages multiple applications executing in multiple containers. So, what are containers? A container is a place where the executable code of applications are packed together with libraries and dependencies that are required to execute the application. These containers are run under the supervision of a container runtime said to be Docker containers. All these containers equally share the resources of the operating system, which make these containers more stable and lightweight to run the applications. Talking about Kubernetes, we have to talk about one important software known as Minikube. Minikube is a software tool that is used to run the Kubernetes locally. It is used to run a single node Kubernetes cluster on your local machine. Clusters are nothing but the number of applications, also known as pods, which are running inside the containers, and all these containers are together running on the container runtime, and all these containers and docker images are together known as nodes, and all these nodes are together called as clusters, and these clusters are controlled by a node known as Kubernetes master, where all the controls such as configurations of containers and other master controllers are present in that. So what is the use of using container based technology? By using container based architecture, multiple applications can share the resources of operating system equally. More specifically, one application may not affected by another application's malfunction or failure because each applications are running on its own containers. Why should I use container based architecture when a virtual machine concept is already available? Because this Docker shares the main operating system equally to the containers so that it does not overload or crashes the operating system, and this is the main reason to use Kubernetes instead of using virtual machines. Now let's understand the working of Kubernetes by running a simple .NET application which has backend services. So the installation flow is represented in this diagram. Firstly, we have to install Docker Desktop which manages the Minikube execution, and we have to install Chocolatey which is a package manager that we are going to use for installing Minikube. So inside Minikube, different services and deployments should be implemented and executed as several pods. Okay, now let's begin installation. Go to Docker's official website and download the extension of the Docker desktop for your desired operating system. And once you execute the extension, accept the policies and it is giving a warning telling us to install the WSL2. WSL2 is the Windows subsystem for Linux that helps to create and run Linux environment and provides several command line tools, utilities, and applications directly on Windows instead of using traditional virtual machine concepts and dual setups. So, to install WSL2, download Linux kernel package. After installing the Linux kernel package, we have to execute the PowerShell command line given in the step 5. And then stop the Docker desktop and restart your computer. And now if you open Docker desktop, you will see your Docker engine is running by showing the green indication on the left bottom corner. To check the Docker's version, open the command prompt and type Docker version, and you will get the current Docker version of your system. To install Chocolatey, get into Chocolatey's official website, go to the install section. Here you can see a set of PowerShell commands to install Chocolatey. To execute these commands, open PowerShell and run it as administrator. So execute the following command: get execution policy. It says restricted. If it says restricted, then we have to type the set execution policy all assign command. So we have set it up. Then we have to paste the installation command, paste it and execute it. Now the Chocolatey package manager is installed. Now let's install Minikube with the use of Chocolatey package manager. Copy the command choco install Minikube and paste it on PowerShell. Once it is installed, type Minikube to get Minikube commands. Then type Minikube version to get the current version of Minikube inside your system. Then we have to set the configuration properties for our hardware to execute the Minikube. So for that, first set config set driver docker, and then Minikube config set memory for 4 GB. Next we have to assign the CPUs. I am assigning 2 CPUs for the Minikube. Now type the command minikube delete, which is used to restart the Minikube by deleting the currently running pods inside Minikube. So it will restart it. And now we are ready to start the Minikube. Type Minikube start. It is giving the error that we are exceeding the memory. So now I am going to set the memory for 3 GB. Now I have reduced the memory configuration for 3 GB. So before starting the Minikube, you can see that no containers, apps or images are running inside the Docker desktop. Now let me start the Minikube and we can see the Minikube is running inside the Docker. Once the Minikube is started, type kubectl get pods and kubectl get services to view the currently running pods and services inside Minikube. But you can see that no pods and services are running inside the Minikube, but our Minikube is running inside the Docker. And to stop the Minikube, type the command minikube stop. Once the installations are over, now we are going to set up our application, which is going to run as one of the container inside the Minikube. In my case, I am using this .NET application as my front end, which has the backend facility of MySQL database. we have to create the configuration files of the deployments and services we are going to use, such as this .NET application and the backend service, in which this configuration helps to connect different parts running inside the Minikube. These are the configuration files about the backend SQL database and the .NET application. This is the configuration file of our .NET application, and these two are the configuration files of our backend service, which is the MySQL database. Here I have used YAML files extension to configure the applications and services. These two YAML files have the properties of backend service. So first, let we implement these two files into the Minikube as a service. So for that, we have to open the PowerShell and get into the location where you have stored the YAML files. Open Docker desktop. Wait until the Docker engine starts. Once your Docker engine starts running, type Minikube start. Once the Docker and the Minikube starts running, we are ready to apply these configuration files inside the Minikube. So to apply these configuration files, type kubectl, apply, targeting file, and the file name. So the MySQL service is created as one of the pod, and we are going to apply the php myadmin. So the php myadmin service is also created and running as one of the pod inside the Minikube. Now, before starting our .NET application, we have to check whether our application's API is correctly directing to the backend MySQL database. So for that, open the .NET application, get into your API service section. So here I have mentioned MySQL/DB. This is nothing but the YAML configuration about the database. Here you can see I have mentioned MySQL database service as my backend service. So I have given the same name inside my application so that my server should target to this service where we have already configured inside our YAML configuration. Set the user and password which you are given to the database. Now we have to create the Docker support file, which will be helpful to create the image for our application, and that image will be uploaded to or pushed to the Docker Hub repository, and our Minikube service will take our application directly from our repository. And to create the Docker service support, right click on your application, add Docker support. I'm adding this Docker support targeting our Linux OS. Once your Docker file is created, copy it and paste it on the path where your solution files are present. Now we are going to create the local image of our application, and we are going to push that local image into the remote repository inside the Docker Hub, and this Minikube service will access our application directly from the repository. Get into Docker Hub's website. Inside the repository, you can see there is no repository is currently available in my account. To create local image of our application and to push it inside our Docker Hub's repository, get into the directory where you have saved your application and type docker build and the name of the application. Once the local image is created, tag the application with the repository name of your Docker Hubs account. Now we are going to push this local image inside the remote repository inside our Docker Hub. So to push the image, type docker push and the repository name and the name of your image. Once the push operation is completed, you can see that your .NET application's local image has been pushed inside the Docker repository as the remote image. So our Minikube can use this remote image to run our application as a container inside the Minikube. Now we have a remote image of our application inside the Docker Hub repository. So now we have to apply the configuration file corresponding to this .NET application. I have named it as full stack YAML file. So now apply this full stack YAML file, kubectl, apply. Before applying the files, make sure that you are in the directory where the files are present. Now to check the pods running inside the Minikube, type the command kubectl get pods. You can see that two pods are currently running and one pod is currently creating the container. So we have to give some time for this pod for creating its container inside the Minikube. After leaving the pods creating its container for a couple of minutes, I am again executing the commands kubectl get services and kubectl get pods. So now you can see our application pod and our backend service pod are currently running and active. And now we are going to check whether our application is correctly working or not. To access the pods which are currently running inside the Minikube, we want to create the URL for the currently running pods. To create the URL for the service, type Minikube service URL and the name of the service. So here I have get the URL for the PHP myadmin, and I'm going to copy this URL and paste it on the browser. Here you can see the table which you have created for your application. Now my table has no values in it. Now let's run the .NET application and check whether it is correctly posting and getting the values in the database. For that we have to open the another PowerShell prompt and we have to get the service for the full stack YAML file, which is the .NET application. Copy the link and paste it on the browser, and I am going to give /swagger. Swagger is a API testing tool. So here I did not actually open the .NET application but checking the API related to the application with the use of the Swagger. First I try to post a task item and check whether it is saved in our database or not. So here you can see the value which we have posted is successfully saved in the database. So our application is working good. From this, we can see that all these applications are running in a cloud which were very portable and can be executed on any machines. This makes great advantage to the developers for creating their applications and can be tested over anybody around anywhere in the world just by creating the image of the application and push it over the Docker Hub and run it via Kubernetes without wasting any resources of the computer. This makes the Kubernetes to become so popular and using among many companies. Finally, I hope from this video you could get an idea about working of Kubernetes and Minikube. Thanks for watching and see you later.